Hello, my name is Omkar Bhende. Atharva Patil and Prasad Pimparkhede are my teammates. Well, Group 12 is our group number. We are going to discuss on design improvements for vegetable harvesting mechanism. Project background. Well, as we all know, underground vegetables are very much important, but harvesting of such vegetables is complex work and needs significant amount of manual efforts and time. One designed harvester which has good performance in terms of productivity and ensures less damage to the vegetables while being harvested. Harvester first digs soil around the vegetables with the digging unit, drags them onto the conveyor. The conveyor pushes the vegetable back while separating the mud and soil that was carried along. Well, in order to perform this operation more efficiently, we decided to work on how to improve the performance of harvesting mechanism. Introduction of the project. The project is focused to study DFM and DFA technique using it in the assembly. These techniques are implemented in the modification of harvesting mechanism. Self-propelled harvesting mechanism was developed for harvesting underground vegetables like potatoes, onions, etc. Harvesting mechanism of existing machine has some drawbacks. We modified that mechanism and eliminated that drawbacks. Well, DFM technique simplified the manufacturing process which results in blade in the modified mechanism assembly, and DFA technique make the assembly process easy for harvesting mechanism. All this assembly has been modeled in Fusion 360. This is the existing harvesting mechanism and this is the harvesting mechanism. Objective of project: to study the design for manufacturing and design for assembly to improve the utilization of mechanism. The next objective is detailed study and analysis of digging and separation system of harvester. Improve blade and separating bars geometry is one of the objective. Improve improper dimensions of blade and stationary plate to reduce the harvesting time, which is our important objective. And the last one is to prevent vegetables from getting damaged by harvester. There are so many factors considered in the design. Well, we studied and analyzed the existing mechanism, and then we came to know that there is a need of modification, and that's why we considered these factors in design. The first one is cultivation pattern, means the different types of cultivation. The next one is various types of underground vegetables. Like we all know, there are so many types of underground vegetables like onion, potatoes. Visibility to operator. The next one is to damage to vegetables. Then cost and size. Then curing of vegetables. And the last one is storage of vegetable after harvesting. Harvesting mechanism. Well, harvesting mechanism is divided into different units. The first unit is digging unit. Digging system used to dig out the underground vegetables from the soil without damaging them and also conveys them to a soil layer with vegetable towards the separating system. The next unit is stationary blade, which is also known as stationary plate. Stationary plate was placed just behind the digging blade so that soil mass along with vegetables was carried from the blade to conveyor unit. The next unit is soil separation unit, conveying system to convey the onions, potatoes like underground vegetables from digging system to windowing system with separation of vegetables from soil and other foreign object, hence the conveyor unit is used. The next unit is selection of conveyor chain. Depending upon maximum tension, selection of chain is done. The last unit is spacing bar. Spacing bars were placed along with the length of the conveyor in order to drop soil between, avoid dropping of onions, potatoes in between. Well, as I told you, there are so many units, but we decided to work on the digging unit and stationary blade to modify the existing mechanism. These are the parts of existing mechanism. Like you can see in the picture, like blade, stationary plate, square spacing bars, sprocket, bearing, shafts, drive chain, supporting plates. Well, these are the parts of the modified mechanism. You can see the most of the parts are remain same, but we change the dimensions. You can see the dimensions of blade and stationary plate. We improved them for the modification. Now my team member Atharv Patil will discuss the further information with you. Thank you.
Hello everyone, this is Prasad. Now I'll discuss the next part, which is DFA and DFM. So DFA is designed for assembly, and DFM is designed for manufacturing. So these two methodologies are used basically to simplify the manufacturing and assembly operations for a certain product. So we considered these things to uh, improve certain parts, which are as follows. The first one that we did is the blade or the tooth geometry. As you can see here, so the initial design was having a little shorter length of the tooth. Then we improved it in order to get a larger or a deeper reach inside the soil surface, so as to optimize the digging operation. At the same time, to simplify the design, whenever we are going to assemble the whole product, where there are 9 such blades installed on the surface plate, the supporting plate. So this is the supporting plate. As you can see, to optimize the design using DFA and DFM, we made certain changes. We changed the supporting brackets that are attached to the vehicle in order to accommodate that digging unit better, and which should provide better operation. So there are a couple of changes that we made. Was we increased the conveyor length from 980 to 1000 mm. That was done in order to provide better stability and provide like smoother transfer of soil when the produce is transferred from digging unit to the conveyor. As you can see, the older conveyor is shorter. The new conveyor that we designed, we increased the length of the conveyor. And the reason for modification of the tooth was to shorten the time required to harvest the crop or the vegetable. At the same time, we could reduce the weight of the individual tooth, so that could in result reduce the overall weight of the unit, and in mass production it will reduce significant amount of material and the cost as well. So this is the whole assembly. You can see the tooth that is attached to the supporting plate, and the plate is mounted on the conveyor. This assembly then we later improved on, and that's how it looks now. So the improved design of the tooth, that is providing a little longer range, so that it can reach deeper inside the surface and properly grab the vegetables and drag it onto the conveyor. This is the exploded view. You can see all the components. There is a conveyor, supporting plate, the bars and the 9 teeth. So to discuss the next part, Atharva will be covering the next slide.
Alright, this is Atharva Patil. Now I am discussing the further slides. You can see on this slide that stress and strain analysis, in which we applied 1000 Newton force on the teeth. This teeth sustained with the force 1000 Newton easily. You can see here. You can see the detailed deformation and stress distribution in the simulation process. In this slide you can see the different CAM processes which we did on the tooth, in which we used different processes for the material removal to get a desired geometry, such as face, adaptive, pocket, parallel, scallop and ramp. You can see the tool path. Scallop and ramp processes are used to get the extra precision of the model. This is the final shape we got before the ramp process, by which we got optimized tooth after the CAM process. This is the codes that we got after post processing, the same one. And these are the conclusion. We studied the design, manufacturing and design for assembly to improve the utilization of the mechanism. Use various available features in Fusion 360 to design, analyze and improve the design of the tooth, such as face. Improved tool geometry was developed, which can improve the harvesting operation while still being strong enough withstand the stress. That we use 1000 Newton. The new part is developed by the performing design for manufacturing and assembly. A manufacturing plan was set up in order to manufacture parts in large scale. Thank you. Also, these are the references that we are used to get the new developed model of the tooth. Thank you, everyone.